All right, so picture this, a black hole. But not, way out there in some far-off galaxy. No, this one's coming straight for Earth.
Yeah, sounds a bit like a disaster movie, right?
Totally. But that's what we're diving into today. We've got some fascinating sources for you, all about how we might, maybe, possibly, deal with this kind of cosmic threat. Like, what would we even DO?
It's a pretty wild scenario, right? I mean, we're talking about total extinction level stuff here. The sources really dive deep on what we could try, and it gets pretty out there. But even the first, more obvious ideas really show just how unprepared we'd be.
Oh, for sure. So first up, the source says, let's just nuke it.
That seems to be humanity's go-to, doesn't it? Big problem. Throw bigger bombs at it.
Right. Like, hey, we've got all these nukes just sitting around. Might as well give it a shot. So imagine this. Every single nuke on Earth launched at this incoming black hole. We're talking a blast of energy 425,000 times stronger than all the atomic bombs used in World War II.
Just try and wrap your head around that scale for a second. It's mind-boggling. But here's the thing. The source explains that black holes, well, they kind of just eat energy like that. It doesn't even faze them.
It's like trying to stop a truck with a spitball.
Exactly. It just underscores how completely outmatched we'd be if we tried to fight a black hole with conventional weapons.
So no epic explosion saving the day.
Yeah.
Instead, the black hole just slurps up all that nuclear energy and actually gets bigger.
Strike one for humanity.
Yeah.
I guess that means bullets and lasers are off the table too.
Definitely. It's clear we need a different approach, something more crafty, as the source puts it.
And that's where things get really interesting, right? We're talking artificial black holes, white holes, even time travel.
Yeah, the source goes there. But before we jump into those wild ideas, maybe we should make sure we understand what we're dealing with,
Couldn't agree more. Sun Tzu said it best, know your enemy. So let's break down black holes for a minute, just the basics, to make sure everyone's up to speed.
Okay, so black holes. They're basically these super dense spots in space, right? And their gravity is so strong that nothing, not even light, can escape.
Yeah, they're like cosmic vacuum cleaners sucking up anything that gets too close. And get this, they're thought to be around 100 million black holes in our galaxy alone.
Whoa. So how do these things even form in the first place?
The source explains that there are two main ways. One is through the collapse of gigantic gas clouds. These form supermassive black holes, the kind you find at the centers of galaxies. They can be 1,000, even 100,000 times the mass of our sun.
So those are the real heavy hitters.
Oh, yeah. But then you also have stellar mass black holes, which form when a very large star dies. Basically, the star explodes in a supernova, but its core collapses in on itself, squeezing all that mass into a tiny space.
Okay, so we've got this black hole heading towards us, and there's this, point of no return, right? The event horizon. Cross that, you're gone.
Exactly. Once you cross the event horizon, the black hole's gravity is so intense that you can't escape. The source gives this really vivid description of what would happen if you fell in feet first.
Oh no, not the spaghettification thing again.
Yep, that's the one. Basically, the gravity at your feet would be so much stronger than at your head, you'd get stretched out like, well, spaghetti.
Yeah, not a pleasant way to go.
And keep in mind, black holes are constantly growing. They're always gobbling up more matter and energy, getting bigger and bigger.
So this black hole coming for Earth, it would be like a cosmic Pac-Man chomping its way through space, getting larger with every bite.
Pretty terrifying thought. And it's not just mass that matters. Black holes also spin, and they can have an electrical charge. It's like they have these extra dimensions of, cosmic personality.
A big black hole with attitude.
Yeah.
But seriously, why does the spin and charge matter?
Well, the source says that these properties, along with the mass, have to be in a specific balance for the black hole to, keep being a black hole.
Like a cosmic balancing act.
Exactly. The source gives this analogy of a marathon runner. Their body temperature and blood pressure need to stay within a certain range to keep going. Same with a black hole. Mess with the balance of mass, spin, and charge, and you might be able to destabilize it somehow.
So maybe there's a weakness there, a way to exploit that balance.
Perhaps. It's fascinating to think that even something as powerful as a black hole might have vulnerabilities.
Okay, well, we know nukes are a bad idea. Time for plan B. Let's fight fire with anti-fire.
The source actually proposes using antimatter.
Antimatter? Like the stuff they use in Star Trek?
Well, sort of. The source explains that antimatter is basically the opposite of regular matter. When they meet, they annihilate each other in a huge burst of energy.
So the idea is to make an antimatter black hole and smash it into the regular one.
Exactly. It's a pretty bold plan, right? But there's a slight catch actually making an antimatter black hole.
I was about to say, that doesn't sound easy.
The source describes this incredibly complex process. You have to accelerate protons to near the speed of light, smash them into iridium to create antiprotons, then slow those down and somehow focus them enough to form antimatter, and then, assemble enough of that antimatter to make a black hole.
Sounds like a lot of steps.
Oh yeah, it's a massive engineering challenge even if we had the technology. And the source says even if we could pull it off, the result is kind of disappointing.
How so?
Well, instead of mutual annihilation, the energy from the antimatter black hole just gets absorbed by the regular black hole. It makes it even bigger.
Seriously. So no matter what we do, the black hole just keeps getting stronger.
It seems that way. So much for plan B.
All right, so we can't blow it up. We can't antimatter it. What about starving it? Could we stop it from eating anything else?
The source addresses that, and it's not good news. Even if we can somehow create a perfect vacuum around the black hole, it wouldn't just disappear.
Right, because it still has all that mass from what it already ate.
Exactly. It would just be a hungry black hole hanging out, waiting for something to come close enough to gobble up.
Okay, so no starving it either. What about overfeeding it? Like with something so weird it might mess it up?
Well, the source does bring up the concept of a white hole, which is like the theoretical opposite of a black hole.
White hole. So instead of sucking everything in, it pushes everything out.
Precisely. The idea is that if we could somehow throw a white hole at the black hole, they might cancel each other out in a burst of energy.
Sounds messy.
It would be a pretty spectacular event, that's for sure. But there's a problem. We have no idea if white holes even exist, let alone how to make one.
So another cool idea, but not very practical for our impending black hole situation.
Sadly, yes.
All right, so we're out of semi-plausible ideas. Time to go full science fiction.
Hit me with it.
The source suggests a time machine.
Whoa, now we're talking, but how would that even work?
Well, the idea is to go back in time to when the black hole was smaller, or maybe even before it formed, and stop it then. The source mentions using a wormhole, which is basically like a tunnel through space-time.
I've heard of those, but do they really exist?
That's the million-dollar question. And even if they do, we'd need a time machine to use them. So another cool concept, but not exactly something we can whip up in the garage. All right, time travel's off the table. What about just hitting it really, really hard?
With what, another nuke?
Nope. The source suggests a super-fast bomb, one that explodes faster than the speed of light. The idea is that if the explosion has enough force to escape the black hole's gravity, it might be able to blast it apart.
Sounds awesome.
Yeah.
But can anything actually travel faster than light?
That's the catch. As far as we know, nothing can go faster than light. It's kind of a universal speed limit. So, another cool idea, but breaks the laws of physics as we understand them.
Yeah.
Okay, so no direct attacks are working. What about trying to deform the black hole somehow?
Deform it? How?
Well, the source gives us 4 options here. First up, attacking its density. Basically trying to stretch it out, make it less dense.
Interesting. But does a black hole even have a size in the conventional sense? Like, is it a solid thing we can stretch?
That's a good question. Some scientists think black holes might have a finite size, while others think they're just regions of infinitely warped space-time. We don't really know for sure.
So stretching might not even be possible, let alone effective.
Exactly. Option 2 is even more out there. Destroying the event horizon itself. The idea is that if there's no event horizon, there's nothing for matter to fall into, and the black hole might just poof.
But the event horizon is what makes a black hole a black hole. How could we possibly destroy it?
Yeah, the source doesn't really go into detail on that. It's a pretty wild idea. All right, option 3. Messing with the spin and charge. Remember how we talked about that balance being important?
Yeah, like the marathon runner analogy.
Right, so the idea here is to crank up the spin or charge so much that the black hole becomes unstable and destroys itself.
Sounds risky.
It is. The source warns that messing with a black hole like that could have some pretty crazy unintended consequences, like maybe even destroying the entire universe.
Yikes. That's a risk I'm not willing to take.
Me neither. Okay, last deformation option. Slow down the spin.
How would we do that?
By dropping matter into the event horizon. Apparently, that can steal some of the black hole's rotational energy.
So we're basically trying to tire it out.
Something like that. But the source says it wouldn't actually make the black hole go away. It's more like slowing down a runaway train by throwing pebbles at it.
Not exactly the most effective strategy.
Nope. So it seems like all these crazy ideas, these desperate attempts to destroy a black hole, they just don't work.
It's starting to feel like we're fighting a losing battle here.
I know. But the source does bring up one last thing, a sort of long game approach. Hawking radiation.
Oh yeah, I've heard of that. It's a quantum mechanics thing, right?
Exactly. Basically, even in the emptiness of space, tiny particles and antiparticles are constantly popping into and out of existence.
Like they just appear and then disappear.
Yep. But near a black hole, one of those particles might fall in while the other escapes. And over a very, very, very long time, that can cause the black hole to slowly lose mass.
So basically, the black hole evaporates over trillions of years.
Exactly. It's like the universe's slowest diet plan.
Not exactly helpful if we need to get rid of a black hole right now.
Nope. As the source says, ignoring your problems doesn't usually solve them, but in this case, it actually does. Eventually.
After a few trillion years, though, so not exactly a solution for us.
Definitely not. So the final verdict from all these sources: destroying a black hole seems pretty much impossible with anything we know or can even imagine right now.
It's a bit humbling, isn't it? These things are just so powerful, so beyond our understanding.
Totally. But hey, at least the chances of a black hole actually heading for Earth are astronomically small.
That's good to know. But still, what if it did happen? What would we do?
Well, the source suggests our best bet might be to just get as far away from it as possible.
Easier said than done.
For sure. But it highlights the sheer scale of the problem. A black hole is such a fundamental force of nature that it almost defies our ability to comprehend, let alone control. So here's a final thought for you. Given all the challenges we've talked about, what kind of future technology, something we can't even imagine yet, might be needed to actually deal with a black hole? It makes you realize how much we still don't know about the universe and what's out there.
Absolutely. It's a reminder that our understanding of the universe is constantly evolving, and what seems impossible today might be within reach tomorrow. Hopefully, we'll never have to actually destroy a black hole, but it's certainly something to ponder.
Definitely food for thought. And on that note, we'll leave you to ponder the mysteries of the cosmos. Thanks for joining us on this deep dive, and until next time, keep looking up.